Hello, friends. Today we will cover two important and interesting topics in basic statistics: Pearson's correlation coefficient and Spearman rank correlation coefficient. So, these are the two very important topics in our statistics, and you will see while we were doing our exercises, you will frequently use these particular topics. So, this is to find out a relationship between two independent variables. Now, to understand this, you should have a basic idea about covariance. So I have already created a video on covariance in my previous tutorials. If you haven't gone through them, I would request you to please and go through them. Also, if you like this video, click the like button and share this to as many as you want. And also, please subscribe my channel. This will be the last topics that I will be covering in our basic statistics, and then I will start a machine learning courses. So whatever will be remaining, for example, maybe some distribution knowledge, some sort of other knowledge that you might require in basic statistics, you can just comment me in the comment section, and I can prepare videos on that. Also, I will also include some other important topics in basic statistics as of when we go along in the course. Because if I teach you everything now, then probably later, if I start a new topic in machine learning and if I want to refer, then it would be again difficult for you guys to come back again in this particular section and search for it and then again start. So better once I start the machine learning course, and as along when I go along, I will cover those stuffs in basic statistics if required. Okay. So having said that, let's start this particular tutorial. So this will be, as I said, it will be, so we need to know what are the differences between Pearson's correlation coefficient, Spearman rank correlation coefficient, and what actually are they, why we require them, and what are the formulas actually. They basically we have formulas for them. So we'll see all these things in today's lecture. It will be a very short tutorial because these two topics are very easy to understand. So let me just straight away start. Okay. Okay. So first topic that we will cover today is Pearson's correlation coefficient. And for this, you should know what is covariance. So if I just want to brush a few things that we covered in the previous tutorial, right, about covariance. So what we found in covariance is basically it helps us to find out the relationship between two random variables. Okay. So what was covariance? It was to find out the relationship, between two random variables. So that was covariance, right? And when I say relationship, what does it mean? Means let's say we have two variables, x and y. So if x increases, whether y also increases or decreases, right? So this sort of relationship we used to find out with the help of covariance. Now there was a formula for this, guys. So the formula for the covariance, so covariance of x and y, if you might remember, it is nothing but 1 by n summation I is equal to 1 to n xi minus mean of that into y of I minus mean of that. So this is the way we used to calculate the covariance. And if it is Increasing, let's say if it's a positive number, we will say that when x will increase, then y also will increase. If it's a negative number, we will say that if x increases, y will decrease. So in statistical terms or in data science terms, we also call some this particular increasing decreasing we call as incremental and decremental. Just remember these points, guys, because these are the few terms which you will see data scientists often using. Okay, so incremental and decremental. So and now, what was the challenge in covariance? If you guys might remember, I already told you that it will only give you a relationship, right? It will tell you whether it's positively related or negatively related. Positively means this one, and negatively means this one. So negative means if x increases, y will decrease, and positive means if x increases, y also increases. So it only gives us the a relationship in the sense that it never tells you what is the magnitude of the relationship. Okay, so that was one of the problems with covariance. So it never tells you, let me change the color, never tells you the magnitude of the covariance, though you will get a number here. Let's say you're getting 3.46, right? But if you're calculating covariance, this 3.46 is exactly not the magnitude of the relationship between x and y. Only we used to see whether it's a positive number or a negative number, and that's how covariance was calculated. So to understand, to know the magnitude of the relationship between covariance, so we have statisticians have two methods, or you can say two statistical tests. One is Pearson's correlation coefficient, and another one is Spearman rank correlation coefficient. So now you know why we require these two statistics, Pearson and Spearman, right? Because there is a limitation in covariance. Limitation was that the magnitude of the relationship cannot be calculated with covariance. I'm writing something stupid. Wait, let me erase it. It's limitation. So limitation. Yeah. So this was the limitation of covariance. Now let me tell you how we calculate Pearson correlation coefficient. So you know why we need Pearson correlation coefficient? Basically to quantify and so this is quantifying, right? When we say quantify means if x increases, y increases or not, or if x decreases, y increases or not. That is called quantification. Okay. So Pearson correlation coefficient quantifies and finds out the magnitude also. Magnitude of the relationship between two random variables. Okay. So this is Pearson's correlation coefficient, two random variables. So, and what is the formula to calculate Pearson's correlation coefficient? So it is denoted as this way. So Pearson correlation coefficient of x and y is nothing but covariance of x and y divided by standard deviation of x and standard deviation of y. So this is the formula, guys. This is the formula to calculate the Pearson's correlation coefficient. And when we calculate the value, whether we will get a positive number and a negative number, and the magnitude of the number, let's say the value of the number, let's say it's 3.62, not 3.62, sorry, because the value will always be lying between 0 and 1, minus 1 and 1. So let me also correct it. So it may be, let's say, 0.98, or it may be around 0.78 minus 0.78, like these numbers. So not only you will get the direction. When I say direction, it means whether this way or this way, right? Direction as well as the magnitude. The value will give us the magnitude. Okay. So now you know what is Pearson's correlation coefficient, right? And one more thing I will explain. So let me go to the other screen. So how we see it basically. So let's say this is the range 0, 1, -1, and this is +1. So if you get a value after calculating the relationship, if you get a value near to this range, near to 1, this is called as highly positive correlation. That means they're highly correlated to each other. That means if X increases, Y will definitely increase. Okay. If it is in this range. Okay. If it is almost near to 0, then it is called as weakly positive correlated or correlation. So it is weakly related. It means that if X increases, Y will also increase, but in a different manner. For example, let's say it increases slowly. It can increase slowly. So if I draw a graph, let's say these are the values of X. So maybe it is maybe like this. It's increasing, but slowly. Okay. So let me erase this. Now, for the negative, so this is positive correlation. Okay, so this is positive correlation, and this is negative correlation. Negative correlation. This can be incremental, and this can be decremental. Okay, so if you find a value near to 1, it will be highly negatively correlated. Highly negatively correlated. It is if it is a negative number and near, it can be weakly negative correlated, like that. Okay. So this is kind of a chart you can refer for the correlation. Okay. Now, why I'm saying you this? Why I'm saying you negative correlations? Because you see, ultimately, what are these -1, 0, 1? These are numbers, right? These are nothing but numbers. So when you calculate this value, when you calculate the value of this particular mathematical equation, you will get a number. You will get some kind of a number x, y, z, right? That particular number is nothing but it will fall in this range. Okay, it can be this one, this one, this one, or this one, and it will have a sign, a positive or a negative sign. When you will calculate, you will see, because you have this formula, right? So you will know after calculation whether it's a positive or a negative number. So this is Pearson correlation coefficient. Why we do it? Because let's say in a data set, you want to understand the relationship between two variables, let's say a dependent variable and an independent variable. So how you can do it? You want to know whether my target variable or the output variable or the dependent variable is having any impact based on the input variables or the independent variables. So to study that, we can use Pearson correlation coefficient. Okay. One more important thing, guys, is Pearson correlation coefficient works only with continuous data. Just remember this; it's a very important point, and it can be a interview question also. It works with continuous data. Okay, and if you plot the graph, if you plot the graph, plot x and y, it is called a scatter plot. I will also discuss different types of plots. Just for now, just bear with me. It's kind of a XY graph. So the relation should be a linear relationship like this. Let's say this is X and Y, or like this. So if in the graph, if you plot the graph between X and Y, and you see this kind of relationship, let's say these are the data points. These are the data points. If you see this kind of relationship, or it can be like this, right? It can be like this. So this is also linear, right? This is also linear. This is also linear. So if you see a linear relationship between X and Y, okay, then it doesn't matter whether it's increasing in the increasing way or in a decreasing way, doesn't matter. Then you go with Pearson correlation coefficient. So you know when to use what, right? So then you can go with Pearson correlation coefficient. It will give you a right relationship. But what if my relationship is monolithic? Monolithic in the sense, let me draw here the graph. Let's say this is X and this is Y, and the relationship is like this. So let's say the values are like this, right? So this is not linear, right? You see, this is not linear. This is kind of a curve. In these scenarios, you cannot use Pearson correlation coefficient. Yes, you cannot use this one. If you use this, then the value that you will get will not give you the actual relationship between the variables. So what we do in these scenarios, also there in real world, maybe always you will not have a linear relationship between X and Y. It can be like this also, right? So it is also known as monotonic. It was also termed as monotonic. Right? So what you will do in this type of situations, then you will go with Spearman rank correlation coefficient. So Spearman rank correlation coefficient. In that scenario, you will use this particular statistical tests. Okay, so you know now where to use what, right? So now it will also have a formula, right? And what is the definition? So it also, let me, if you, it also quantifies, the relationship and finds out the magnitude of monotonic relationship between two ranked variables. Now see the difference, guys. In previous correlation coefficient, I talked about just two random variables. Now here I am talking about ranked variables. So I already discussed about this monotonic. Now you need to understand what is rank, right? That's why it is written as Spearman rank correlation coefficient. So now what is this? Let's understand this. So let me go to the different page. Let me write it down again. Spearman rank correlation coefficient. Okay. So now we'll discuss about the rank. So how actually it is calculated? So you see the formula or the process is like this. Let's say you have two variables, x and y. Okay. And let's say these are the random numbers that I may add. Let's say 25, 15, let's say 17, 11, 7, 3, 15. Sorry, 15 is already there. So let's say it is 18, right? 1, 2, 3, 4, 5, 6, 7, 8. Let's say I have two variable more. So 25 and 12. So we have 10 variables. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Similarly, here also we have uh, similar like this. We have the variables for y also, values for y also. Let's say 36, 71, let's say 29, 55, 84, 46, 16, 13, 7, and 98. Okay. So now we have been given a job to find out the relationship between x and y. Okay. So what is the rank? So in Spearman rank correlation, we should understand rank. So basically, how you rank it. So every variable, when you will calculate this Spearman correlation coefficient, you have to rank them, and based on their rank, we will find out the relationship. Now, how to rank them? So ranking is done in this way. So let's say if I give a new variable name for this one, let's say XR, rank for X. Similarly, YR, rank for. So the highest value in this particular series of the X random variable will get the rank 1. Okay. And the lowest will get the rank 10. So there are 10 variables. So the lowest number will get the rank 10 and so on. It will increase. So here if you see, what is the lowest number here? 3. So it will be rank 10. Then lowest number is here 5. So it will be 9. Okay. Then 7. So it will be 8. Then if you see here 15, right? 12. So it will be 7. Then 18 or 15. So it will be 6. Then this will be 5. This will be 4. Sorry guys, I might have let me correct it again. There may be issues here. I missed the 11 actually. Let me do it again. Okay. So 3 is the small, so it will be rank 10. Then the number is 5, so it will be 9. Then 3, 5, 7, so it will be 8, rank 8. Then 11, so rank 7. Then 12, rank 6. Then 15, rank 5. 10, 9, 7, 6, right? Then 5, then this one, 15, 17. So this is 4, this is 3, this is 2, and this is 1. Okay. So this is how we rank them. Again, I'm telling you how we are ranking it. So the highest number in this variable will have the top rank, and the lowest number will have the last rank. So there are 10 variables, right? So the lowest will be 10, highest will be 1, right? So if you see here, the highest is 25. So that's why I'm ranking it as 1. Lowest is 3, right? And that's why I'm ranking it as 10. And subsequently, we'll follow the same process. So this is how we calculate the rank for this variable. Now, similarly, for this one also, you calculate the rank. Okay. So how we'll calculate? So you see the rank, which is the highest, say 98, right? So rank 1. And then after 98, it is 84, rank 2. Then after this, rank 3, right? Then 71 is done, 55, rank 4. Then after this, 46, right? So rank 5. Then 6, 7, uh, then which one? 8, 9, and 10. So we also calculate similarly for the variable y. Now you will calculate the difference between the ranks. So once you calculate the ranks, so you will calculate the difference between the ranks. So here, what is the difference? 2 minus 6 is minus 4. 9 minus 3 is 6. 5 minus 7 is minus 2. 4 minus 4 is 0. 7 minus 2 is 5. 8 minus 5 is 3. 10 minus 8 is 2. 3 minus 9 is minus 6. 1 minus 10 is minus 9. 6 minus 1 is 5. I hope this is clear, guys. This is nothing but XR minus YR. Okay. So first what we have done, we have calculated the ranks. How we have calculated the ranks? The highest one, the highest value, in fact, is rank 1, and then subsequent numbers. Similarly for Y also, we did the same. And then we found out the difference between these two ranks. And this is the value. Then we will calculate D square. Okay. So what is D square? It is 16. This is 6 equals 36. It is 4. It is 0. It is 25. It is 9. It is 4. It is 36. It is 81. It is 25. So we calculate D square as well. Now let me give you the formula for Spearman rank. So formula for Spearman rank is X and Y is equal to 1 minus 6 into summation of I is equal to 1 to n di square divided by n into n square minus 1. So this is the formula for Spearman rank correlation coefficient. So now it is easy for you guys, right, to calculate this one. You know these values already. Just put it over here. N is nothing but the total number of observation, which is 10, and you can easily calculate the value. So now the value, if it is a positive number, that means it is positively related. If it is a negative number, it means a negatively related. And how much, by how much it is related, that is the magnitude. So value will tell us the magnitude. So this is this is something that we learn about Spearman rank correlation coefficient, and where we can use it also. In this cases also we can use in normal linear regression, sorry, not regression, linear relationship also we can use. So meaning you can use it for anything. You can use it for this one also. Linear. This is also linear, but it's monotonic. Okay. You can use it for this one also. And Pearson's you can use only in case of this. Sorry, this is not linear. This is monotonic. This is a kind of a curve. It's not linear. Sorry. These are linears. So this, for this one, you can use only Pearson correlation. You cannot use this in this kind of relationship. You cannot use Pearson. You can use Spearman rank. And Spearman rank you can use for both this one as well as for this kind of relationship as well. So how and what you will do first? First of all, you will plot. First of all, you will plot a graph between X and Y. Okay, X and Y. You will plot a graph. You will see the relationship. If it is kind of like this or if it is like this, you can go with either of them, right? But if it is only this kind of relationship, you cannot go with Pearson. You have to go with Spearman rank. So this is the difference. Okay. Now what else? Okay, one more thing. In Spearman rank correlation coefficient, you can also use it for ordinal variables. Now, you might have heard this term ordinal, right, guys? Because I have already discussed this in my previous classes. Again, if you haven't gone through those videos, make sure that you go through them so that it will be easy for you to understand. Ordinal means the variables which are having some numbers, discrete numbers, basically discrete numbers in order. Maybe say ranking. You have ordered a food and someone have asked you to rate them. So that's the ordinal variable, right? So you can use it on ordinal variables as well, in continuous variable as well, in ordinal variable as well. Whereas the Pearson correlation coefficient cannot be used for ordinal variables. You cannot use it. There's a limitation for Pearson correlation. One more thing is for nominal variables, nominal variables, you cannot use either Spearman or uh, Pearson. Okay, like categories and all categorical variables, you cannot use. For that, maybe you can use some other sort of correlation coefficients. Okay, other sort of correlation coefficients. Maybe let me just. Other sorts of correlation coefficient may be like Kendall, Taube, or Goodman, or Kruskal Gamma. So these are the alternatives for Spearman correlation. Okay, so that's all, guys. So this is, I guess, this is what we discussed, and I hope that I have covered everything in these two topics. Yeah. So now the job for you will be to find out few tasks in Google and use these formulas. Okay, this is for Pearson. You can find out any problem statements. You know the formula now. What are the formulas and when to use it? So you can use these formulas. Okay, so thank you, guys. This was a short video on these two topics, and with this, I will be ending the basic statistics. Whatever will be remained in basic statistics, I will cover in once I start my machine learning algorithms and all. And in between, if I want, or if I will think that yes, it has to be there, I will include them. Don't worry for that. But this is the minimum statistical knowledge that you should have to start with with machine learning algorithms. Okay. So with this, I'm just signing off for this video. Thank you. Thanks a lot. Keep learning, keep shining. Do share my videos if you like them. Click the like button and subscribe my channel. Thank you.